Yeah, good morning to all of you. In the previous lecture, we have discussed the importance of Hamiltonian dynamics over Lagrangian dynamics. Hamiltonian is basically function of generalized coordinate, generalized momenta and time. And we have discussed what is Hamilton's equation of motion and what is the relation between Hamiltonian and Lagrangian. So, in this lecture, I will discuss that how to express a Hamiltonian in different coordinate system, or how to write the expression of Hamiltonian for a given L. So suppose we have the simplest coordinate system is Cartesian coordinate system. So we will focus on that. So what is, let's say we have a Cartesian coordinate system. Which is XYZ coordinate system. So how to express the Lagrangian Hamiltonian expression, or for a given L how to write H. So I have already explained what is L. L is basically T minus B. So which is 1 by 2 m x dot square plus y dot square plus z dot square minus v of x, y and z. So I am talking about the general profile of potential v, x, y, z. So what is H now? How to write H? So we know that H is basically function of generalized coordinate. Let's say this is qk, generalized momenta and time. But our L is, what is our L? L is simply qk dot and time. So what is difference? L is a function of generalized velocity and H is a function of generalized momenta. So what is our job? Anyhow we have to replace. So replace qk dot by pk dot in H. So basically H is T plus V. For a conservative system, our H is sum of kinetic plus potential energy. And so what is our H? H is basically 1 by 2, kinetic energy is 1 by 2 mx dot square plus y dot square plus z dot square minus v of x, y and z. This is for conservative system. If this is for a conservative system, means our Lagrangian is independent of time, our Hamiltonian is independent of time, then only we can write our H represent total energy, which is sum of kinetic plus potential energy. Otherwise we cannot write. If our potential, if our Lagrangian is time dependent, then we cannot. We will go for another relation, which is H equal to pk dot minus l dot t. So this is very, now H is half kinetic energy plus, this is not minus, this is plus t plus v. But what is our H? H is a function of q, p and t. But here it is function of qk dot. So anyhow this is not the correct expression. So this is not the correct expression of H, because in this our H is simply function of H, qk, pk and t. But in this expression, in this Hamiltonian expression, we can see that our H is a function of velocity, that is x dot, y dot, z dot. So that is why we can say that this is not the correct expression. So how to obtain the correct expression of H? How to obtain? Because anyhow we have to convert our H, or anyhow we have to express our Hamiltonian in terms of generalized coordinate and generalized momenta instead of generalized velocity. So but here this is function of generalized velocity. So this is not the correct expression of H. So how to obtain the correct expression? By using, how to obtain the expression of or correct expression of H. Expression of H or correct expression of H. So using concept of generalized momenta. So using concept of generalized momenta. Using concept of generalized momenta, we can simply find out the, and what is generalized momenta? So generalized momenta is, so these are very important points. Generalized momenta is simply del L upon del QK dot is PK. So with the help of this concept, we can replace our velocity in terms of momentum. Means with this expression, we can replace our QK into PK. So using the concept of generalized momenta, we can replace our generalized velocity in terms of generalized momenta, and we can write the exact expression of Hamiltonian. So what is del L upon del QK dot? So with this expression, this is our Lagrangian, and what is our QK in this case? QK is x, y and z, and L is simply 1 by 2 mx dot square plus y dot square plus z dot square minus of v, x, y and z. So del L upon del x dot is generalized momenta corresponding to x coordinate, which is px. This is mx dot. So this implies that x dot is px by m. Similarly, for y coordinate, del L upon del y, this is py, this is my dot, which implies that generalized velocity along y direction is py by m. Similarly, del L by del z dot, which is pz, which is mz. This implies that this z dot generalized velocity in terms of momenta is pz by m. Now putting the value of x dot, y dot, z dot from here, let's say this is equation 1, this is 2, and this is equation 3. So putting the value, and this is equation 4. Now putting the value of x dot, y dot, z dot from 4 in 3, from 4, equation 4 in 3. So what we have? We have simply 1 by 2, x dot is px by m. So this is px square by m square, and m will cancel out, and what we have? Px square by, let me just px square by 2m plus py square by 2m plus pz square by 2m. This is kinetic energy plus vxy z. So now this is h, qk, pk, t is, there is no t term. So now we can see that our Hamiltonian is function of generalized coordinate and generalized momenta instead of generalized velocity. So now this is the correct expression of h, and this is the way to write the expression of h for a given L. This is simplest coordinate system. We can write the Hamiltonian for different coordinate system. So just go through. This is quick revision. If for a given L, our L is in our, if we have a profile of L in this way, which is simply Cartesian, so how to obtain h? And this L is time independent. There is no t term. So we can simply write h is t plus v, and we can find out the we can replace our generalized velocity by using concept of generalized momenta. So by doing this, we will have the final expression of Hamiltonian, which is in generalized velocity, generalized coordinate and generalized momenta. Thank you.